Hello everyone, I am A.S. Kritik of class 8. I am going to prove and by experimenting the three laws of motion by Newton. What are these three laws of motion? The three laws of motion is the laws which are to be followed by any object that is in motion or in rest. The laws of motion are three in number. The law of inertia, the force is equals to mass times acceleration, and the third law is every reaction has an opposite equal reaction. Well, first let me prove the first law of inertia. The law of inertia. There are two types of law of inertia of motion and inertia of rest. Inertia of motion says that a body has the tendency to be in constant motion unless and until being acted by an unbalanced force. Let's do it out. Here I have taken a card and I have placed a 2 rupee coin on top of it. Here I have taken a dictionary as the barrier. Now, when the card comes at full speed and hits the dictionary, the coin flies away. Why does the coin fly away when the card is being stopped? Let's do this activity slowly. When the car is moving at very high speed and it dashes the dictionary, the speed of the car is reduced, but the coin, which is also moving along with this car, has still the same speed. So it moves in the same speed away from it until it meets an unbalanced force from the table and stops here. Thus, inertia of motion is true. Well, how come inertia of rest can be true? And what is inertia of rest? Inertia of rest, the tendency of an object to be at rest unless and until an unbalanced force acts upon it. Well, we can try it out. Here I have taped two 2 rupee coins together, and this is a glass and this is a cardboard. I have placed them, and here. If I hit this, people would say that the coin along with the cardboard would fly off somewhere, but when I hit it, something interesting happens. See, the coin did not fly off with the cardboard or fall down over somewhere else. Instead, it just straight went down to the glass. Why is that so? Because when the coin was here over the cardboard, it was at rest, and when I hit the cardboard alone flew. The coin is actually at rest, so its tendency to be at rest even though its base is moving. This is called inertia of rest. The tendency to be at rest is called inertia of rest. That's why without any support it just fell down into the base of the glass rather than being flown through this. This law of inertia can be viewed in real day life in many places. Like, for example, when you are driving the car, when the car is going slowly and suddenly starts to accelerate, your body thinks that you are in rest due to constant velocity, and when you start to accelerate, you involuntarily move yourself backward. Why is that so? Because when you move yourself back, you move yourself backward because your body thinks you are at rest and you are at the point before the car started accelerating. Then the body overcomes the tendency and becomes along with the motion of the car. Now, along with the motion, inertia of motion. Now, sometimes when you are going when the bus suddenly halts to brake, you go forward like this and come back in the seat. Why do you involuntarily go forward? This is again the law of motion. You see, your body has the tendency that you move forward, but you are not actually moving. You move forward, then you think your tendency is over, then you come back. This proves in everyday life that inertia of rest and motion are true. Okay. The third law of motion is every force has an opposite and equal reaction force. Well, here is a bouncy ball, and when I drop it on the desk, it bounces back. Why does it bounce back after it touches the desk? People say it is very compressible and so spring reaction takes place. No. When the ball touches the table, the ball exerts some amount of force on the table, and the table again shows the same reaction on the ball. That's why the ball is able to come up. Otherwise, if the ball would hit the table and the table would hit the floor and the floor would go on plummeting down towards the center of the earth and it goes on. That's why. But people would ask, wait, why is that the ball hits the table and table does not move downwards? That is because due to the difference in mass. Already, the second law of second law of motion states that force is equals mass times acceleration. Thus, if force is high, mass is high, and force is high, the acceleration must be high. So, here the acceleration is somewhat mediocre, and the mass of the ball when compared to this table is very less. This table may be around 100 kg and this ball just around 10 grams. So, when the mass is very less. So when the ball hits the table, the force applied by the ball to the table is equal to the force applied by the table to the ball. Thus, due to the less mass, acceleration is more over here, and due to the higher mass over here, the acceleration is so small that it cannot be seen with an unaided eye. This is the same way. But people would ask, is this just when two objects hit each other? No, when two objects repel each other or attract each other too, the same reaction takes place. For example, when you jump, the earth pulls you towards the center of to the center, but actually you are also pulling the earth. Newton also proved that every object in this universe has its own mass. Thus, you do have your own gravity, but that's not the case here. You are jumping. When you jump, you are exerting a force. The ground is pulling you with a certain amount of force, and you pull the ground with the same amount of force. But again, the mass plays a great role. The weight of the earth is around a billion cube, while your weight is just a mere 50 to 100 kgs. So the mass, due to the difference in mass, the earth pulls you easily towards itself rather than the earth being pulled by you. So the second law of motion is mass and acceleration are proportional to force. So it is technically like, if force is high, then the mass must be high, or if the force is high, the acceleration must be high. So if the force is x, then the mass and acceleration must be somewhat up and down. So if the mass is high, then the acceleration must be low, so to get a result. And if the mass is low, then the acceleration is high. They will get the same force, even though people might say this came very fast, or this is very high mass. If the acceleration is low in the very high massed object, or if the mass is very low in the high accelerated object, then the force will be equal. That's all. Hope you understood it. Thanks for watching the video.